before, I discovered how to prove the powers of 11 rule, but as we don't have any more time, I guess we can't do that. And just as a closing remark, we've discussed the properties and applications of Pascal's triangle, along the way illustrating the almost magical connections in the world of numbers.
Okay, in your binomial expansion, you discussed sigma summation.
Yes.
Okay, can you explain that further?
Yes. Yeah, I didn't have time to explain it in the presentation, but sigma notation is basically a short way to represent a series or a sum of many terms, like in an expansion. And we set the parameters by calling each term number k. We start k somewhere. Here, k starts at 0, and we end it at somewhere n. So if we want to express something like x plus y to the n, we have to give the form of each individual term in terms of k. So x to the k, the first term 0, k equals 0. X to the k would be x to the 0, which equals 1. Y to the n minus k, depending on what n is, it'd be n minus 0, so n. So n changes as k increases, it decreases, and x increases as k increases. K is the term number, and the form of an individual term depends on k.
Okay, so to go along with that,
Yep.
could you on the board put
The chalkboard?
Yep, chalkboard.
Yep.
There's a piece of chalk there.
Yeah.
Okay, parentheses a plus b. Okay, cubed to the third power.
Oh, yeah.
Okay, using Pascal's triangle, could you
Yeah.
tell us what the binomial expansion would be?
So, do you want me to use Pascal's triangle in order to construct an expansion?
Mhm.
Okay. So, ignoring the n choose k from the binomial theorem, as we know this is a coefficient, we construct Pascal's triangle in order to determine the coefficients without solving for an identity. So we'll just construct first 4 rows. These will be the coefficients for the expansion. From the binomial theorem, we know x exponents decrease, y exponents increase. So we have x cubed with coefficient 1 plus x squared y. This is actually y to the first. This was y to the 0, that's why it's absent, with a coefficient 3 plus 3 x cubed, x to the first, which is just x, y squared plus 1 y cubed. It's actually x to the 0th power, which explains its absence. So this is the expansion for a plus b cubed, or x and y cubed, using coefficients from Pascal's triangle.
Nice. I'm just curious. You have 5 resources in the back of this paper. Which one did you use most to gain your knowledge from? Because obviously it's not just from one website, right? Or did
Yeah.
someone instruct you a little bit? Did somebody instruct you a little bit too?
Well, yeah, I got the beginning step of the proof for Pascal's rule from my dad, and then I just finished the proof myself. And then from there, I can construct the proofs for others. Of course, I didn't have time to show them, but I mostly used I got most of my stuff from a book.
Nice job. Good. Thank you.
Thank you.